At 11:18 on the morning of September 1, 1859, a quiet man in the English countryside became the first human being ever to watch the sun attack the Earth. Within about 18 hours, the sky itself would seem to catch fire from the Arctic to the Caribbean, and the most advanced technology on the planet would begin sparking, burning, and sending messages with no power source connected at all. His name was Richard Carrington. 33 years old, the son of a wealthy brewer, he had turned his back on the beer business to spend his money on the sky. At his private observatory at Red Hill, south of London, he had devoted 7 years to one of the most patient tasks a person can choose, drawing the sun. On every clear day he projected the solar disk through his telescope onto a screen. You never looked directly, that is how astronomers went blind, and he sketched the sunspots, those dark bruises drifting across the solar surface, one careful pencil line at a time. That morning, the sun gave him something worth drawing. An enormous cluster of sunspots had crawled onto the disk, a knot of dark cores so large it could reportedly be seen through smoked glass. Carrington was sketching it, alone in the hush of the observatory, when it happened. 2 beads of light ignited among the spots. Not the ordinary light of the sun, something harder. Blinding, white, and moving. His first instinct was to doubt his own equipment. He thought a stray ray of unfiltered sunlight had leaked through his apparatus. It hadn't. The light was coming from the sun itself, 2 brilliant points swelling and sliding across the sunspot group like burning kidney beans. He understood he was seeing something no one had ever recorded. So he did what a careful Victorian scientist does, he ran to fetch a witness. By his own account he was gone barely 60 seconds. When he returned to the screen he was, in his own word, mortified. The light had already collapsed into 2 fading pinpoints. 5 minutes, beginning to end. That was the entire show. Except it wasn't. Miles away in London, an amateur astronomer named Richard Hodgson had been watching the very same sunspot group, and he saw the same impossible white light. 2 independent witnesses. And there was a third witness neither man knew about, a machine. At Kew Observatory, the magnetometers, delicate instruments tracing the Earth's magnetic field onto photographic paper, twitched at almost the same moment as the flash. The sun's radiation had slammed into our upper atmosphere, and the Earth had flinched. What Carrington had seen was a solar flare, the first ever observed by human eyes, and, we now believe, one of the most powerful on record, an explosion releasing something like the energy of billions of atomic bombs. And behind that flash of light, something slower and far heavier was already on its way. A coronal mass ejection, billions of tons of magnetized plasma torn loose from the sun and hurled toward the Earth. Here is a detail that makes the event stranger still. The sun had already fired once. In the last days of August, an earlier storm had lit auroras and unsettled compasses around the world. Scientists now believe that first eruption swept the road clear, thinning out the solar wind between the sun and the Earth, so that when the September 1 ejection launched, it crossed 93 million miles in roughly 17.5 hours. A typical ejection takes 2, 3, 4 days. This one arrived at a dead sprint. It struck in the early hours of September 2nd. And the night sky, all over the world, went insane. The aurora is normally a polar phenomenon, a pale curtain reserved for Norway, Alaska, Siberia. That night, crimson auroras blazed over Havana. Over Panama. There were reports from Jamaica, from Hawaii, from ships far out at sea. A few claims from near the equator are still debated, but the low-latitude sightings are documented beyond doubt. In many places the light was bright enough to read by. Witnesses described reading a newspaper in the street at 1 in the morning. In New York and Boston, crowds gathered on rooftops and sidewalks and simply stood there, faces tipped upward, watching curtains of red and green ripple across a sky that had no business burning. In the Rocky Mountains, and this story ran in newspapers at the time, so take it as reported rather than proven, gold miners woke beneath the glow, mistook it for dawn, and started cooking breakfast. Birds were said to sing at midnight. Across America and Europe, people poured into the streets. Some were certain a great fire was consuming the next town. In places, fire crews reportedly turned out to fight a blaze that was hanging in the sky. Others dropped to their knees, convinced the day of judgment had arrived. Witnesses described the heavens as blood, as burning drapery, as an immense crimson arch pulsing slowly overhead. To understand what happened next, remember what kind of world this was. No power grids. No radio. No electric light in any home. To almost everyone alive, electricity was a laboratory curiosity, a parlor trick with frog legs and brass spheres. With one enormous exception. The telegraph. In 1859, the telegraph was barely 15 years old, and it was the internet of its age, over 100,000 miles of wire lacing North America and Europe together. That night, the network went haywire. A geomagnetic storm drives electric currents through the ground and through any long conductor it can find, and suddenly every telegraph line on Earth was a live antenna plugged straight into the sky. Operators were knocked back from their keys by electric shocks. Sparks leapt from the brass instruments. At some stations, reports say, the chemically treated telegraph paper caught fire on the desk. Signals dissolved into gibberish. Whole networks fell silent, or worse, kept transmitting on their own, sounders chattering with no hand on the key. Then came the strangest telegraph exchange of the 19th century. On the line between Boston and Portland, Maine, the operators found their batteries useless, the storm's current was overwhelming them. So Boston sent, "Please cut off your battery entirely for 15 minutes. Portland answered, "We'll do so. It is now disconnected. Mine is disconnected, and we are working with the auroral current. How do you receive my writing?" "Better than with our batteries on." For nearly 2 hours, the line ran on nothing at all, no batteries, no power supply. The machines were being driven by the storm itself. Operators called it working on celestial power. The exchange was published within days, and it remains one of the best documented moments of the entire event. The storm surged, faded, and surged again through September 2nd. Magnetometers at Kew and Greenwich were driven clean off their scales. We don't even possess a complete recording of the peak, because the traces literally ran off the paper. Modern estimates of its true intensity vary, and scientists still argue over the numbers. But by nearly every measure we have, it remains the most intense geomagnetic storm in recorded history. And then the sky healed, the wires quieted, and the arguing began. Carrington laid his sketches beside the magnetic records and saw the connection between the flare and the storm, but he refused to overclaim. "One swallow," he wrote, "does not make a summer." The scientific establishment was even more doubtful. Years later, the great Lord Kelvin insisted the sun simply could not deliver that much energy to the Earth. He was wrong, but proving it took the better part of a century. Coronal mass ejections were only directly confirmed by spacecraft in the 1970s. Carrington's own story ends in shadow. Within a few years he had largely abandoned the observatory, dragged back to the failing side of the brewery business, worn down by ill health and personal troubles that turned genuinely dark. He died in 1875, only 49, shortly after the death of his wife, in circumstances Victorian newspapers found scandalous and historians still find sad. He never knew that his name would become the benchmark for solar catastrophe. But astronomers still count the sun's rotations exactly the way he numbered them, Carrington rotations, thousands of them now, one after another, to this day. So how big was it, really? For years, researchers believed Greenland ice cores held the storm's chemical fingerprint, a spike of nitrates frozen into the ice. That claim has since largely collapsed. The nitrate evidence is now widely doubted. What we do have is something stranger: tree rings. Radiocarbon locked in ancient wood shows that in the year 774, the Earth was struck by something far more violent, a so-called Miyake event, quite possibly an extreme solar storm that dwarfed 1859. In other words, the Carrington Event is not the ceiling. It is simply the biggest blow to land since we started building our world out of wire. And that is the part that matters. In 1859, the only wires were telegraph wires. The world lost a few days of messages and gained the greatest light show in living memory. Run the same storm today, and the picture changes. We have had previews. In May 1921, a storm that some modern studies rank close to Carrington's class burned out telegraph and railway signal equipment and reportedly sparked fires in stations. In March 1989, a storm far weaker than Carrington collapsed the Hydro-Quebec power grid in about 90 seconds, 6 million people in darkness for 9 hours, in winter, and a transformer in New Jersey damaged beyond repair. And on July 23, 2012, it very nearly happened for real. The Sun launched a Carrington-class eruption straight through Earth's orbit. It missed only because our planet had passed that exact point about 9 days earlier. A NASA spacecraft, Stereo A, flew through the cloud and measured it. By several measures it rivaled 1859. One published estimate afterwards put the odds of a Carrington-class storm striking Earth at roughly 12% per decade. Scientists debate that number. None of them put it at 0. What would it actually do? The honest answer is that nobody knows precisely, and the serious studies say so. Long high-voltage transmission lines are the modern telegraph wires. Storm-induced currents can overheat and damage the giant transformers that anchor our power grids, and the largest of those take many months to replace. Satellites can be degraded or forced into safe mode, GPS and radio can falter, polar flights get rerouted. A 2008 U.S. National Academy's workshop sketched a worst case costing $1 to $2 trillion, with recovery measured in years, a scenario estimate, it must be said, not a prophecy. But here is the calm part, because this is not a doomsday story. It is a warning shot that we actually heard. Unlike the world of 1859, we now watch the sun every hour of every day. Coronagraphs see an eruption the moment it leaves the sun, usually giving 1 to 3 days notice of arrival. Sentinel spacecraft parked a million miles upstream feel the storm's true strength shortly before it reaches us. With warning, grids can be reconfigured, transformers protected, satellites put to sleep, flights moved away from the poles. Operators have rehearsed for this, forecasting centers in the United States, Europe, and elsewhere run watch floors around the clock, the way meteorologists watch hurricanes. Richard Carrington got 60 seconds, and he made them count. We would get the better part of a day. The question is no longer whether we will see the next one coming. It is whether we will take it seriously when we do. Because somewhere on the sun, right now, the magnetic knots are quietly winding tighter. The next great storm is not a question of if only of when, and of whether the lights merely flicker for one strange, beautiful evening, or go out for a season. If you want more forgotten history that sounds made up but isn't, subscribe and I'll see you in the next one.